discuss first law of thermodynamics. First law of thermodynamics. This first law of thermodynamics is also known as law of conservation of energy. Okay? It states that energy can neither be created nor destroyed, although it can be converted from one form into another. I repeat, according to first law of thermodynamics, energy can neither be created nor destroyed, although it can be converted from one form into another. Now, this first law of thermodynamics has been stated in several other ways also, but the basic idea remains the same. The basic idea is the conservation of energy. So it can be stated in other forms like the total energy of the universe always remains constant. Again, it is the same thing. Okay? The third form says that the energy of the system that is isolated from its surrounding is constant. So you can see, although there are different languages, but the basic theme is the same, that the energy is conserved. Now, what is the justification? So let us discuss justification for the first law of thermodynamics. How can we justify first law of thermodynamics? Well, I have already told you earlier that these laws are basically no laws. These are the human experiences. But since nothing contrary to these statements, these laws have been proved so far, therefore these are called the laws. So the first law of thermodynamics has no theoretical proof. It is a law based on human experience. The following observations justify the validity of this law. Number one, you know very well that it is not possible to construct a perpetual motion machine. That is, we cannot produce or construct a machine which can perform work, which can do work without the consumption of energy. Okay? So, no car can be made which can work without consuming petrol or diesel or battery or any kind of energy. Okay? Now, if the first law were not correct, then it would have been possible to construct such a machine. But we know very well that the perpetual motion machine cannot be produced, and therefore we can say that the first law is correct. The second thing is that James Joule in 1815 conducted a large number of experiments regarding the conversion of work into heat energy. He found that for every 4.183 joule of work done on the system, 1 calorie of heat is produced. He also pointed out that the same amount of work done always produces same amount of heat irrespective of how the work is done. So these things simply justify the first law of thermodynamics or the law of conservation of energy. Now let us discuss the mathematical expression for the first law of thermodynamics. Now this is important for solving numerical problem. So mathematical expression for the first law of thermodynamics. Well, we already know that the internal energy of a system can be changed in two ways. Number one, by allowing heat to flow into the system or out of the system. And number two, by doing work on the system or by the system. Clear? Okay. Now let us consider a system whose internal energy is U1. So internal energy, initial internal energy is U1. Now suppose if the system absorbs Q amount of heat. Then what is the internal energy of the system? So the internal energy of the system becomes U1 plus Q, isn't it? U1 was the internal energy initially, and then Q amount of work, the Q amount of heat has been absorbed by the system. So obviously, when the system absorbs energy, its internal energy increases, and therefore the system has the total energy U1 plus Q. Now suppose W is the work done on the system. Okay? Now suppose the W amount of work is done on the system, then its final energy becomes U2. Okay? So U2 becomes U1, which was the initial internal energy, plus Q amount of work, Q amount of heat has been given to the system, and then W amount of work has been done on the system. So we can say that U2 minus U1 is equal to Q plus W, or change in internal energy delta U is equal to Q plus W. Now this delta U is equal to Q plus W is the mathematical statement of the first law of thermodynamics. What do you mean by this relationship? It means that the change in internal energy is equal to heat added to the system plus work done on the system. Clear? So this is the mathematical form of the first law of thermodynamics. We have to use this formula to solve the numerical problem. Now suppose a system does work on the surrounding, then what will happen? Right now we have seen that the system has gained Q amount of heat and W amount of work has been done on the system. So the total energy has increased. So delta U is equal to Q plus W. Now I am asking you, if W amount of work is done on the surrounding, then what will happen? Obviously, the internal energy of the system will decrease. So in this case, work is taken as negative. You know very well that if work is done on the surrounding, if work is done by the system, it is taken as negative. So, suppose Q is the amount of heat added to the system and W is the work done by the system. Then the change in internal energy becomes what? Delta U is equal to Q plus, it should be Q plus W, but since work is done by the system, so it will be minus. So now it becomes delta U is equal to Q minus W. So please try and understand. This is the relationship delta U is equal to Q minus W when Q amount of heat is absorbed by the system and W is the amount of work done by the system. So in this case, change in internal energy is equal to heat added to the system minus work done by the system. Now the above relationship between internal energy, work and heat is a mathematical statement of the first law of thermodynamics. So delta U is equal to Q plus W or delta U is equal to Q minus W, depending upon whether the work is done on the system or by the system. Now, if we substitute W is equal to minus, W is equal to minus P expansion delta V, P delta V, then what happens? Then delta U becomes Q minus W is P expansion delta V. Now if the process is carried out at constant volume, okay, then what will happen? Then delta V becomes 0. And when delta V becomes 0, then what happens is delta U is equal to Q, simply Q. Now this is the Q which is QV. So please understand finally that delta U is nothing but QV. What does it mean? It means that delta U is nothing but it is the heat absorbed or evolved in a reaction at constant temperature and volume. Now this concept is very, very important. Is it clear? So delta U, change in internal energy, is nothing. It is QV. QV means heat absorbed or evolved in a reaction at constant temperature and volume.